So good afternoon, my YouTube viewers. It is Crystal here, and basically what I wanted to do is I wanted to give you a code review on Kaggle's Digit Recogniser competition, which is the MNIST dataset, but I know I misspelled it on my Jupyter notebook. I called it MNIST instead of MNIST. I'm going to give you a code review because I'm going to make a blog post on this, and I like to do code reviews on blog posts when I can. And so today I'm studying Keras Tensorflow at the moment, and so all of my data sets that I made predictions on using like sklearn and XGBoost and like GBHum and stuff like that, I'm going through and I'm making predictions with Keras Tensorflow. And the reason why is because Keras Tensorflow is a neural network, and because it's a neural network, it's supposed to have higher accuracy. So like it's a type of deep learning, really. So like when you have machine learning, at some point the accuracy will plateau, but with deep learning, which is where you get into neural networks, the accuracy, it just keeps on learning and keeps on becoming more accurate. And so that's why generally neural networks win competitions, although sklearn, they do well. I mean, they do well in competitions, but they don't generally win them. It's normally the neural networks that win the competitions. And so I don't know if I'm ever going to win a competition because I'm not living in the United States. And basically in Kaggle, if you want to collect the prize for a competition, you have to be in the United States. So I don't know if I ever will win a competition, but I certainly like entering competitions, doing code reviews and blog posts. And so that's where I get my satisfaction, even though while I'm not in the United States, there's not really much incentive for me to actually win a competition since I can't collect the prize. Okay, so with the MNIST dataset, I got a 97.67% accuracy, which was an improvement over my previous prediction. And my previous prediction was something with sklearn. I don't remember exactly what it was because I've used all kinds of models in sklearn. Some of them, sklearn does have a neural network called MLPC. So it could have been an MLPC, but I used Keras Tensorflow's neural network. So we have our problem statement. MNIST, Modified National Institute of Standards and Technology, is the de facto Hello World dataset of computer vision. Since its release in 1999, this classic dataset of handwritten images has served as the basis for benchmarking classification algorithms. As new machine learning techniques emerge, MNIST remains a reliable resource for researchers and learners alike. In this competition, your goal is to correctly identify digits from a data set of tens of thousands of handwritten images. We've curated a set of tutorial-style kernels which cover everything from regression to neural networks. We encourage you to experiment with different algorithms to learn firsthand what works well and how techniques compare. So that's your problem statement. So the first thing we're going to do after we've created our Jupyter notebook, and which is free on Kaggle, is we're going to import our libraries. So we're going to import NumPy as NP, which carries out numerical computations. We're going to import Pandas as PD, which does data processing. We're going to import sklearn, which is Python's machine learning library. We're going to import TensorFlow as TF, which is Python's neural network. we're going to import matplotlib.pyplot.splt, which enables you to visualize the data, and we're going to import seaborn SSNS, which also enables you to visualize the data, and we're also going to import OS, which is an inbuilt library in Python, which goes into the operating system. So now what we're going to do is we're going to load the data sets, and we're going to use OS to do that. It's going to go into the operating system, and it's going to retrieve the files. And in this instance, we've got 3 files being train, test, and sample submission, and they're all CSV files, which is comma separated values. And then what we're going to do is we're going to read the data sets with pandas. So with pandas, we're going to read the data sets and convert them to data frames. And the 3 data frames that we used are train, test, and sample. So you can see train here, and the label is column number 0. Which is interesting because normally the label is the very end, but in this one they made the label column number 0. And then in test, we don't have a label in test because test is going to be what we are going to make predictions on. And then this is your sample. So that's what Kaggle is going to want to see when we submit our predictions. We check out the train file, and it just says it's a range index of 42,000 entries, 0 to 41,999. It's got 785 columns, label to pixel 783. It's an integer. We check test info, and it's the same thing. It's got 784 entries, pixel 0 to pixel 783, and it's just your test file. We're going to check for null values. Fortunately, we don't have any null values. We're going to do a disk plot,